Today's goal is to evaluate trigonometric expressions. Okay, let's start with example 1. Evaluate, meaning from the value, the number. Evaluate the sign of pi over 3. Okay, I'm thinking to myself, pi over 3 is an angle. Remember these guys? You can cut pi, that's 180 degrees, but we don't need to talk about degrees. You can cut this angle pi into 6 pieces, or think about the bold as cutting pi into thirds. So pi over 3 would be 2 pi over 6, right here, or 1/3 of the way to pi. So let's draw that angle. I'm going to sort of exaggerate. It's closer to the y-axis than it is to the x-axis. I'm going to make a reference triangle by dropping a vertical line up or down to the x-axis. You should make a right angle with the x-axis. Then I'm thinking to myself, pi over 3, is that coming from an isosceles triangle? No, that doesn't really make sense. It's coming from a scalene triangle. Oh, where the longer side is root 3 over 2, and the shorter side is root 1 over 2, or just 1/2. In this case, because getting to this point requires going to the right, this 1/2 is positive, and going up, this root 3 over 2 is positive, and the hypotenuse is always positive 1. So sine, sine is opposite over hypotenuse, so that would be root 3 over 2 over 1, which gives us root 3 over 2. All right, example 2. Evaluate the cosine of 3 pi over 4. 3 pi over 4. Ooh, this time I'm cutting pi into fourths. That's going to land me halfway between the x and y axes. So here I've divided 1 pi into 4 pieces. I want 1, 2, 3 of the pieces the way there. So that edge will land right here. I can mimic that shape. I need to land halfway between the x and y axes. And because I'm landing halfway between the axes, again making a reference triangle by dropping a vertical side, that makes a right angle with the x-axis. Oh, these two side lengths must be the same. They'll both be root 2 over 2. But this time, to travel to this terminal point, the point where you end or terminate, I went left, so this side must be negative. And then here, I'm going up again. Up is a positive direction, so that'll be positive. Cosine is adjacent over hypotenuse, so that'll be, keeping in mind, again, the hypotenuse is always positive 1. Adjacent is that negative root 2 over 2 over positive 1. You get negative root 2 over 2. Example 3. I need to evaluate the tangent of, let's do 7 pi over 6. You don't have to put the parentheses in. I usually like to, because it helps us remind ourselves the angle is something you're putting inside of the function cosine, much like 9 is a number you can put inside of the square root of 9, cosine of 3 pi over 4. You don't have to put those parentheses. Not in this. Okay, 7 pi over 6. Cutting pi into teeny tiny pieces into 6. 1, 2, 3, 4, 5, 6, 7. That's going to land here. Let's mimic. It's moving closer to the x-axis this time. I'll exaggerate because it helps me see, oh, this side is clearly longer. It must be a scalene triangle where the longer side is root 3 over 2, the shorter side is 1/2. Now I'm thinking left direction to finish up. That makes this side negative. Down makes this side also negative. Hypotenuse is always positive 1. Tangent is opposite over adjacent, so I get negative 1/2 over negative root 3 over 2. I know that dividing fractions means multiplying by the reciprocal. So I'm flipping this second fraction, one on the bottom. I'm going to let its negative sign float up top so I don't forget about it. Negative times negative, oh, that'll be positive. 2's cancel out. I get positive 1 over root 3 root in the denominator. So I can multiply by root 3 over root 3. And we get the square root of 3 over 3. Square root of 3 squared, the square root, and the square cancels out. Tangent of 7 pi over 6 is square root of 3 over 3. Okay, just two more. Let's look at evaluating the tangent of pi over 2. Okay, pi over 2 is halfway to pi. Oh, so that will land us here. You can't draw a reference triangle for pi over 2 because you'd want to draw a vertical line down to the x-axis. Well, that's exactly on the angle itself. So if you can't draw a reference triangle, you're going to label the coordinate pair where it lands. It's coming from the unit circle, which has radius 1, so that's why this y value is 1. You didn't go left or right, so that's why the x value is 0. Now I'm reminding myself the y value is the sine. If I ask for the sine of pi over 2, it would be equal to 1. The x value is the cosine, so the cosine of pi over 2 is 0. And tangent, you can think of as opposite over adjacent, or if you have to, you can think of it as sine over cosine, which in this case would be 1 over 0, can't divide by 0, this is undefined. Okay, last problem. What if I use the same angle and asked you to evaluate the cosecant of pi over 2, the secant of pi over 2, and the cotangent of pi over 2. I'm keeping them in this order because cosecant is the reciprocal of sine. Secant, abbreviated SEC, is the reciprocal, meaning you're just flipping the fraction of cosine. And cotangent is the reciprocal of tangent. So cosecant. Well, sine of pi over 2 is 1. 1 is the same as 1 over 1. When you flip 1 over 1 around, you still get 1 over 1, which is 1. Secant. Well, cosine of pi over 2 is 0. 0 is the same thing as 0 over 1. When I flip 0 over 1, I get 1 over 0, which is undefined. Cotangent would be the reciprocal of tangent. Well, tangent was sine over cosine, which is 1 over 0. If I flip 1 over 0 around, I get 0 over 1, which is